The process of factoring, part 1. Remember factor trees. A while ago, suppose you were given the number 60 and you were told to write that as a factor tree. What you would do is you would think about numbers that multiply together to give you 60. So maybe you would have thought of 6 times 10. And then you would keep going and say, well, what numbers multiply together to give me 6? Well, 2 times 3. And what numbers multiply together to give me 10? 5 times 2. So you've probably seen factor trees before. For us in algebra, this definition of factorization, what it means is it's the decomposition or the breakdown of a polynomial into a product. So multiplying a product of other terms or factors, which when multiplied together give the original, put you back to the start. So for example, if I gave the number 15 and I said, factor 15, you would say, oh, well, 15 is 3 times 5. Because I know 3 times 5, when I multiply those together, puts me back to 15. The aim of factoring is usually to reduce something to what we call these basic building blocks. So simply put, for us, to factor an expression, all it means is we want to rewrite it as a product. We want to have an expression and we want to write it as a product, as something, whatever, times something else. That's what a product is. Why do we do it? Once an expression has been factored, we can actually divide out equivalent factors. I want to notice the link here as well at this point. If I have this initial expression on the left, if I have 4 bracket x plus 2, and if I'm told to expand that, we use the distributive property. We go 4 times x, that gives us 4x. We do 4 times 2, that gives us our 8. That's the expanding part. Factoring is the reverse. Factoring is back this direction. Factoring is, I'm going to give you this side. We're going to start, almost like we're starting with the answer. We're going to start with this, and I'm going to say, what did we have initially? What was the expression we had before we multiplied it out? Because if we notice this on the left-hand side, this is a factored expression. This is written as something times something else. This is something times something else. Now there are a few different ways or a few different types of factoring that we need to be aware of in grade 10. The first kind is called common factoring. And a couple rules here. A common factor can be divided out of every term in the polynomial. Now there's going to be two things going on. There's going to be numbers and there's going to be variables. So for the number, we're going to look for the greatest common factor. And for the variables, we're going to look for a common variable and we're going to take the lowest exponent. So let's try some examples and this will make sense. So the question would be common factor. Now suppose we have 10x plus 20. So what I'm going to say to myself is, what is the largest number, what is the greatest number that divides evenly into 10 and 20? That number is 10. So what I do is I then write that common factor out front and I put my brackets down. And I say to myself, what do I have to put into this bracket so that when I did my distributive property, I end up with this expression over here, 10x plus 20. And for these simple ones, we can just kind of work it out in our head with our understanding of integers. We know 10 times x is 10x, and we know 10 times 2 is 20. So if I were to use the distributive property here, I would go 10 times x, 10x, 10 times 2 is 20. How about this one? The largest number that divides evenly into 25 and 100. That would be 25. And I notice there's an x in both terms. There's an x squared and an x. So the x is also common. So the rule is I'm going to take out the lowest power. So there's like a 1 up there. So I'm going to pull out this 25x to the 1. I'm going to write that out front and then put my brackets down, and then I'm going to say, okay, well, 25x times something has to give me 25x squared. That's x. And 25x times something has to get me back to 100x. And that would be 4. So this is now factored. This expression, this binomial, is now written as something times something else. That's factored. How about this one? Take a second and look at it. Okay. I look at 4, 12, and 16 and realize 4 is the largest number. I have an x to the 1, x to the 2, x to the 3, so x to the 1 would be my common factor, 4x to the 1. And then I just tinker with it a bit and say, okay, what do I have to write in here so I know when I do my distributive property, I'm back where I started? Well, 4x times 1 is obviously 4x, 4x times 3x, 12x squared, and so on. 4x times negative 4x squared gives me my negative 16x cubed. How about this one? Take a second, look at it. Okay. 8 and 12, the largest number is 4. I have a's in both. A2 is my lowest power. And I have b's in both. B2 is my lowest power. So that becomes my common factor. And then I just say, I have to multiply this times something to get there, and multiply this times that to get there. Now make a note here. You are allowed to divide out common factors. You may not cross out or cancel similar terms. And this part gets tricky for kids. So I'll show you an example here. Suppose we have a question, just 3x plus 6 over 3. And I say plug in x equals 2. Okay, it's easy. So 3 times 2 plus 6 over 3. 3 times 2 I know is 6, plus 6 is 12 over 3. The answer is 4. Got it. Now, if I were to factor first, I look at my numerator, I have 3x plus 6. I notice there's a common factor of 3 here. So I'm going to write the 3 up front, and I'll say, what's left in my bracket? Okay, 3 times x is 3x, and 3 times 2 is 6, so that has to be my bracket. And then I can divide out common factors in the numerator and the denominator. I can do this division part. 3 divided by 3 is 1. And that leaves me with x plus 2. So now, when I plug in my x is 2, I get my same answer, 4. So when we factor and we reduce the expression, that could save us a little bit of work in the long run. Now, sometimes kids get a little bit confused, it gets tricky, and they would sort of divide out the 3 on top and 3 on bottom. This isn't factored. This top part isn't factored. This is a sum. That's add. That's not a product. That's an addition. And if you start dividing out things through an addition, if I put a 2 in here, if I replace that with a 2, 2 plus 6, I wouldn't get 4, I would get 8. I would get the wrong answer. So you're not allowed to cross things out if there is an addition or a subtraction. It has to be factored. It has to be multiplying. Okay, that doesn't work. The last one here for this video is factoring by grouping. Sometimes we can put a large polynomial into groups and find a common factor for each part. So it's really just common factoring just a couple times. So for example here, ax plus cx plus ay plus cy. I take a look at the first two and take a look at the second two, and I see x is common, there's an x there and an x there, so I pull my x out. What would I have left? A plus c. I know I'm right because I can go x times a, ax, x times c, xc. And the same thing over here, y is common. I can pull out the y out front and have my a plus c. And now we notice that a binomial, a plus c, is common to both of them. So a plus c can actually be a common factor. So I would then pull this a plus c out front as common and sit it over here. And then I'd say, well, what would I have left? I had the x here and I had the plus y there to finish that second bracket. Okay, that's it.